Except with their solutions, we're going to be showing their solutions both on a number line and algebraically because the standard says you have to know both. So we're going to be making sure we know how to do it both ways. This first bullet, the easiest way to understand absolute value inequalities is to translate them using the language of distance, just like I did with the equations. So the example I gave you says the absolute value of x minus 4 is greater than 3. What this means is that the distance between x and 4 is going to be more than 3 units. So with our equations, the distance was equal to something. The distance between x and whatever was equal to 3. Now we're saying it's more than 3. But again, if we are looking at 4, I could go 3 to the right or I could go 3 to the left. So if I were to go 3 to the right, 1, 2, 3, but it's got to be more than that. So to show that on a graph, we could have that open circle and then shade anything to the right because it's got to be more than 3 units away from this value 4 in the middle. But just like we could go to the right 3 units, we could also go to the left 3 units and we'd be at 1. But again, it's going to be more than those 3 units. So to show that, we could use an open circle and then we'd shade to the left. To show anything below 3 could be a part of this, below 1 could be a part of this solution, and then anything above the 7 could also be a part of this solution. So on a graph, that's that is how we would show it without these little clouds that I drew to show you those 3 units. And then if we were to write this algebraically, our solution would be the union of those 2 shaded regions. So we'd be writing our solutions as inequalities or with the interval notation. So if we were to do this using the interval notation, we would have a parenthesis and put from negative infinity to the 1. And then again, we're going to have that parenthesis. And then we'll use that union sign and then show our next batch of solutions, which would be from 7 to that positive infinity. And again, using those parentheses because it's going to be more than 3, not more than or equal to. So we use those parentheses because they're not included. Those next 2 bullet points are just some special scenarios. So this first one, if you have the absolute value of x plus 5 is less than -1, what that means is that the distance between x and -5 is less than -1 units. But distance is always positive. It cannot be less than -1. It can't be -2, -3, -4, -5, because again, it always has to be positive. So when you have an absolute value that is less than a negative, that is going to never be true because absolute value always produces those positive answers. So if you got to this step in your solving process, you'd be done because you'd say there's no solution or DNE or whatever, okay? The opposite of that, if you were to get something like the absolute value of x plus 5 is greater than or equal to a -1, so again, meaning the distance between x and -5 is greater than or equal to -1, that's always true because distance is always positive. So it's always going to be greater than -1. It's going to be 0 or 1 or 2 or 3 or 4 or 5, whatever that is. Okay? So these are the 2 kind of special cases that you need to look out for when you're solving, because in this case, you're going to have no solution. And then in this case, it would be all values, anything from negative infinity to positive infinity. Because again, the absolute value will always be greater than a negative, always, because it's positive. All right. So now that we've kind of talked about what absolute value inequalities are, let's go ahead and practice a couple solving. So what I've done is I've broken down the steps for you right here. And as we walk through them, we'll work through this example problem. So our example problem is the absolute value of 2x minus 4 minus 2 is less than 12. So we're going to start the same way we would with an equation. First thing we want to do is isolate the absolute value part of this inequality. So I'm going to bring this -2 over to the other side. So I would add that 2. So I get the absolute value of 2x minus 4 is less than 14. Now that it's isolated, we're going to create our two cases, just like we would with the equations. But with an inequality, our first case is going to stay exactly the same. So we're going to have 2x minus 4 is less than 14. Our second case, we have to switch the sign. So this is going to be 2x minus 4. We need to switch the sign and make that positive 14 and negative 14. Really, just like we did with the equations. So I've given you guys this little acronym. Hopefully it will help you remember when you break it into the two cases. The acronym is KISS for keep it, meaning keep this first one exactly the same, and then switch. So on your second case, you need to switch the sign and switch the positive to a negative. So keep it, switch. All right? Now that you have your two inequalities, you just solve them. So this part is easy. Add the 4. 2x is less than 18. Divide by the 2, which means x is going to be less than 9. And then if I do the same thing to the negative 14, I would add the 4 to the negative 14. 2x is going to be greater than negative 10. Divide by the 2. X is going to be greater than negative 5. So now that we have solved it, we're going to represent our answers both graphically and algebraically. And then I've given you some asterisks here to remember on a graph, if your inequality signs are just less than or greater than signs, then you should have open circles on our solutions. If they are less than or equal to or greater than or equal to, you should have a closed circle on that number line. So when we are graphing these solutions, you need to also make sure that your number line goes from least to greatest. So one solution is at 9, one solution is at negative 5. Well, you need to make sure your negative 5 is down here and your 9 is on the right. So on negative 5, I'm going to have an open circle. And on 9, I'm going to have an open circle because this is just a less than sign and this is a greater than sign. So what you will notice about these two solutions, if you go to graph them, this says that x is going to be less than 9, which means to the left. But x is greater than negative 5. So that would be to the right. So when you graph this, your solutions would be anything in between that negative 5 and the 9. Once again, because it's less than 9, but greater than the negative 5. Okay? So I didn't write this down, but I want you guys to add this to this little section. Because what I want you to recognize is that if you have a greater than or a greater than or equal to inequality sign, that's going to graph like an or compound inequality, which means when you graph them, they're going to graph apart. But if we have a less than or a less than or equal to sign, that's going to graph like an and compound inequality, and that's going to graph together. So if you go back to our example, our inequality sign on our example was a less than sign. So because it's a less than, that's like an and compound inequality, and that's why our solutions graphed together versus apart. So anytime you have a less than sign, like we do here, that graph better shade together. If you look at your inequalities and they're shading in opposite directions, you've done something wrong. They need to graph together. Okay? Now we need to represent this algebraically. So we are going to use interval notation and inequality notation. I know, so many notations. But if you use interval notation, well, that's just when we would list our minimum to maximum. And again, because we have these open circles, it would just be from -5 to 9. That would be that interval notation. And if we were to write this using our inequality, then we would have our minimum value, -5, is less than x, which is less than 9. So anytime you have an and solution, that x is going to be in the middle of that minimum and maximum point, because that's what this shows here. The solutions are in between -5 and 9. So our x is in between -5 and 9. And on your delta math that you do today, it's going to want your answers like this, which is why we're going over it, so that you know what to expect. All right. So that was a lot of info. Let's practice a couple more times so that you feel a little more comfortable, and then you can get started. So we've got the absolute value of 4x plus 7 plus 4 is less than or equal to 23. So less than, this is going to graph like an and compound inequality. So the x is going to end up being in between. So if we isolate the absolute value part, we subtract the 4. So we've got the absolute value of 4x plus 7 is less than or equal to 19. Now that we have the absolute value part, we're going to make our two cases. And remember, our two cases are keep it, switch, switch. So we're going to keep the first one, 4x plus 7 is less than or equal to 19. And then the second one is going to be 4x plus 7 is greater than or equal to -19. And this is how we're going to get that x in between our two values. And now's the easy part, because now we just solve them like you would solve an inequality. So we subtract the 7. 4x is less than or equal to 12. Divide by 4. X is less than or equal to 3. Subtract the 7 now from the -19. 4x is greater than or equal to -26. Divide that by 4. X is greater than or equal to -6.5, -6.5. So again, since this is an and compound inequality, it means that our x values are going to be in between -6 and 3. So when we go to graph that, make sure you have the -6.5 down here and the 3 here, so that your number line's in order from least to greatest. Both of the circles on those solutions are going to be closed because they're less than or equal to or greater than or equal to. And then again, that shading would be in between because we have that and inequality. So now if we were to write this solution using our inequality notation, we would have, can't decide if I want to put it on above or below, but we'll do -6.5 is less than or equal to x, which is less than or equal to 3. And then our interval notation, we would use brackets because these are included. So we would use a bracket, put our minimum value, which is -6.5, comma, maximum value, and then a bracket on the other side. So these are your two algebraic ways, and then this is your graphical way. Okay? So not as bad as maybe the example seemed because I felt like I said so much, but not that bad. Okay, Let's go on to number 2. 2/5 times the absolute value of 5x plus 10 minus 14 is greater than negative 6. So again, the first thing, just like with our equations, we want to isolate this absolute value. So we're going to add the 14. So we get 2/5 times the absolute value of 5x plus 10 is greater than 8. Now, since the absolute value is being multiplied by 2/5, I'm going to divide by the 2/5 or multiply by 5/2, whichever. So we get the absolute value of 5x plus 10 is greater than 20. We have a greater than sign too. So just giving you a heads up with that greater than sign, these are going to be like an or compound inequality. Since it's greater, say it funny. It'll help you remember. Greater. Yeah, it'll help you. Okay. All right, but now that it's isolated, we're going to make our 2 little cases. And we're going to keep the first one the same. 5x plus 10 is greater than 20. And then the second case, we're going to keep it, or we're going to switch the inequality sign and switch it to a negative 20. Now is the easy part. Just solve the inequalities. Minus 10, minus 10. 5x is greater than 10. I'm running out of space, which means x is going to be greater than 2, because we would divide by 5. And then if I subtract the 10 from a negative 20, I get 5x is less than negative 30. Divide that by 5, and I get x is less than negative 6. So if I were to graph that, I have my negative 6 down here, my 2 down here. I will have open circles on both of those. But again, since this is a greater than sign, it's going to graph like an or compound inequality, and they're going to graph apart. This inequality says that x is less than negative 6. So less than negative 6 would be to the left. And this inequality says x is greater than 2. So that would be to the right. So your graph would be graphing away from each other. So when we write this algebraically, we'll start with inequality notation and then we'll do interval notation. So the inequality notation is easy because it's already right here for us. So this just means we would have x is less than negative 6 or x is greater than 2. That's your inequality notation. Which, again, this is how it's going to want it on Delta Math. So you guys have that example. But you also have to know how to represent this using interval notation. So this left section of our graph would be anything from negative infinity to negative 6. So negative infinity to negative 6 with parentheses because it's not included. And then we'd use that union. And the right side solutions are from 2 to positive infinity. So then we do 2 to positive infinity, and that would be your interval notation. So again, your Delta Math today is going to want it like this, but like my Open Math will tell you if they want interval notation, so you'd have to write it like this. But it'll tell you what notation it wants. So you just have to know all of them. I know. Yes. All right, 2 more, and the next one is going to be quick. Are you ready for me to go on to the next one?
I can't remember if this one was not.
For the notes right up here with these special cases. If it is a less than sign, if it's less than a negative, that can never be true. You would write like no solution or DNE or whatever. If it's greater than, you would write all real numbers. if it wanted you to shade,
Sorry, just,
did you look back at the top of the notes?
yes, and
The top of the notes will tell you.
No, but because it's greater than or equal to, it should be fine. It's always.
Right.
So if it's all I have to put is always.
Mm-hmm.
So I just did always work for nothing.
Yep. All right, so if I look at my next problem, I'm going to isolate the absolute value part first. So I'm going to add the 8. And I get the absolute value of 2x minus 1 is greater than or equal to -7. The absolute value is greater than or equal to -7.
Always.
No.
Oh.
Can't be.
Yes.
It can't be greater than a negative, but absolute value is always positive.
Exactly.
So it means...
It's always.
It means it will always be greater than or equal to a negative because absolute value is positive. It's never true if it's less than a negative. It's always true if it's greater than a negative because it will. It's always going to be positive. So it's always going to be greater than a negative. So it would just be from negative infinity to positive infinity, or you can write all real numbers or whatever. That's what's at the number line. You would literally shade the entire thing because from negative infinity to positive infinity.
I'm just going to say.
All right.
Or send.
Always true. Good. Okay. One last one, which isn't as quick, but goes over some good things that we need to remember about inequalities. So again, the first thing you want to do is isolate the absolute value bar. This negative is not attached to this 8. This is like a -1 coefficient in front of the absolute value. This is just a constant of 8. So move that first, subtract the 8 from both sides so that I'm left with the negative absolute value of 7 minus x is greater than or equal to -5 minus 8 is -13. Yes, always with any inequalities. So Miley went ahead and answered what I wanted y'all to make sure you remember. We now have to divide by a -1. And any time with inequalities, you can never forget this rule ever. If you are dividing by a negative, you have to flip the inequality sign to keep it true. So now, all of a sudden, I have the absolute value of 7 minus x is less than or equal to 13. So now it's a less than or equal to, which means this is going to be like an and, because less than, it's an and. Yes, it's going to graph together. Say it. It will help you. All right. So now we create our two cases. 7 minus x is less than or equal to 13. And 7 minus x is greater than or equal to -13. Keep the first one, switch on the second one. Remember that KISS acronym. All right, so now we subtract the 7. So we get -x is less than or equal to 6.
Because you divided the negative again.
And so then now, just like Marley said, since Miley, I'm sorry, I have a Marley too, and I have a Marley like niece, so Miley, I'm sorry. I have to now divide by a -1 again. But once again, if I divide by a negative, I have to flip it. So x is greater than or equal to -6. And then my second inequality, when I come to solve it, I get -x is greater than or equal to -20. But once again, I have a -1x, and I need a positive x. So I divide by that -1, and I get x is greater than or equal to a +20. I did not flip the sign, even though I just told y'all to flip the sign. Less than or equal to 20. So now when we graph this, we would have our -6 down here and our 20 down here. And it's going to graph like an and inequality because it's greater than or equal to the 6, but less than or equal to the 20. So you're going to see that they're going to graph together. So both are closed circles, and we graph together. Which means if we're writing it as an inequality, -6 is less than or equal to x, which is less than or equal to 20. And if we're writing it as an interval, we would use the brackets. We would do the bracket, -6 to 20, and a bracket. Unless those were open circles. Like if it was just a greater than or a less than, then they'd be parentheses. If it's not included, it's parentheses. If it's included, it's a bracket. Okay? All right.